Welcome back to KQ's channel. This is Madam Chan here. Today we are going to continue with Mathematics Chapter 6, which is about systems of linear inequalities in two variables. In the previous lesson, you have already learned linear inequality in two variables, right? So what is the difference in between the linear inequalities in two variables with this one is that the system of linear inequality in two variables, it involves a combination of two or more linear inequalities. Okay, we look at the next slide over here. This is what we are going to learn today, which is a system of linear inequality in two variables is going to divide it into four parts here. First, we are going to learn on how to represent situations in the form of system of linear inequality. You've learned this before, just that we are going to try to represent the situations in a few more linear inequalities. Okay, next you are going to make and verify the conjecture about the points in the region in solution of linear inequalities in system. So you are going to find out where the point is going to lie on which region above or below and so on. And then the third one, you are going to determine and shade the region that satisfy a linear inequality system, which is about the same as the one that we have did before. And the last part is problem solving. Okay. Now we are going to see how to determine the appropriate inequality for a certain situation. So y is greater than x, you have learned before already. The linear inequality is y greater than x like this. Y is less than x, it will be y less than x like this. And then for y is not less than x, it will be y is greater than or equal to x. So we are going to see the combination not the combination, the inequality which involve greater than or equal to first. Like this one also greater than or equal to, right? You already learned the keyword. Y is at least k times x. So if it is at least, then you are going to use the symbol of greater than or equal to. Same with this one. Y is greater than or equal to k. We are going to see the word minimum of y is k, the word minimum. Okay, and then the rest will be y is not more than x, that is less than or equal to. Y is at most means not more than that, right? So less than or equal to. And maximum is also less than or equal to. And then the last three is a bit different here. Sum of x and y is greater than k. So sum means x plus y. So you can see x plus y is greater than k. And then difference between y and x is less than k. So difference means you minus, right? So y minus x is less than k. And then y is more than x by at least k. So y is more than x means y minus x. Y minus x, sorry. At least means greater than or equal to. So greater than or equal to k. Okay, now we look at example 1 here. During recovery movement control order, the MCO, Taken Bakery Shop has set the rules following the new norm. X adults and Y children are able to enter their shop. The people are selected according to the following conditions. So we are going to find out what is the linear inequalities that are going to be represented over here. A, the total number of people that can enter the shop is at most 8. So if the number of people that can enter the shop is at most 8, which means it is less than or equal to 8, right? And then for X adult and Y children over here, it means the total of people that can enter. So X plus Y is less than or equal to 8. So you can see the solution here. X plus Y is less than or equal to 8. For B, the number of adult is not less than the number of children. So adult is X, children is Y. Not less than means it must be greater than or equal to. So X is greater than or equal to Y. And then for C, maximum number of children is 4. So children is represented by Y, meaning that the maximum, it must be less than or equal to. So Y is less than or equal to 4. Okay, do you have any problem with this? No, right? Okay, we continue. So here we are going to determine the conjecture about the points in the region that satisfy a system or linear inequalities. In the previous lesson, I already mentioned the meaning of conjecture, right? It's like a guessing or assumption. So meaning that we are going to guess where is the points is going to be situated in which region. Okay, so you look at the question here. Based on the diagram, determine the region that satisfies the inequality x plus y less than or equal to 8 and y is greater than or equal to 3. So for this inequality here, x plus y is less than or equal to 8, it is drawn in this line. Okay, x plus y equal to 8. When you draw the line, we always use equation x plus y equal to 8. But when it comes to inequality, then you must use the equals inequality signs. Okay, and then y is greater than or equal to 3. In the equation will be y equal to 3, right? So y equal to 3 is this line. Okay, now we are going to determine the region. For example, the region A. Region A with 0.22. So where is 0.22? I'm going to show you 0.22 here. This is 2, 2, this part, 0.22. Okay, from the inequality that we have earlier, x plus y is less than or equal to 8. I use a pointer so that you can see. So x is equal to 2. Y is also equal to 2, meaning that 2 plus 2 is less than or equal to 8. 2 plus 2 is a 4, right? It's less than or equal to 8, right? So you need to find out whether it's true or false. The answer is true. And then you look at the second inequality over here. Y is greater than or equal to 3. So the value of y is 2. 2 is greater than or equal to 3. Correct or not? No, right? So it is a false. Okay, then you look at region B. This is region B here. We get point. The point is 3, 4. 3, 4 is over here. Okay, so the value of x is 3. The value of 4 is, the value of y is 4, which means inequality x plus y will be 3 plus 4 is less than or equal to 8. 7 is less than or equal to 8, right? So it is true. And then for the coordinate of y, it is 4. 4 greater than or equal, 4 is greater than or equal to 3, so it is also true. And then for point C, for 0.27, does it situated in the correct region? So 2 plus 7 is less than or equal to 8. It is a false because it is 9. 9 is greater than 8. Okay, and then for inequality, y greater than or equal to 3, the value of y is 7, right, from here. So 7 is greater than or equal to 3, it is a true. And then the last one for region D, this is region D over here. The coordinate is 8, 1, this part here. Okay, so 8 plus 1 is less than or equal to 8. It is false because 9 is greater than or equal to 8. And then the coordinate y here is a 1. 1 is greater than or equal to 3 is also a false, right? Okay, so you need to make sure both the inequality is true, only then it satisfies the inequality x plus y is less than or equal to 8 and y is greater than or equal to 3. So from the given point that we have just now, let's see. Okay, first one, true, false. So we cannot consider this anymore. It doesn't satisfy because one true, one false. True, true, both satisfy, right? Okay, which means region B satisfy the inequality x plus y is less than or equal to 8 and y is greater than or equal to 3. Okay, and then this one is false. This one is true, also not. And the last one, false, false, also does not satisfy. So the only one that satisfy the inequality is this. Okay, 0.34. Okay, what does it mean actually? If you look at the inequality x plus y is less than or equal to 8 on the graph, so we can see the region that is covered up by the graph is the region below here. And then for the second inequality, y is greater than or equal to 3. So y is greater than or equal to 3. If you refer to the graph, this line y equal to 3 here, greater than or equal means that it is the region above. So the part that is shaded twice is this part here. I changed the color into blue here. You can see this part is shaded twice. Okay, therefore the point that satisfies the two inequalities it must be situated in region B here. Okay, Now we look at the second question, second example here. Determine and shed the region that satisfy a system of linear inequality. So example 2, shed the region that satisfy each of the following system of linear inequality. We look at diagram A first. Y is less than or equal to x plus 3 and x is less than or equal to 2. So if you look at y is less than or equal to 3 here, is this line, right? Y equal to x plus 3. So less than or equal to means that the graph, the region is below the graph, right? So you shed this part. It is at the bottom. Done. Okay, then you look at x is less than or equal to 2, this line here. X is less than or equal to 2 meaning that is on the left. So which is the region that satisfies both the inequality? The region that is shaded twice. So what you can do is, after you have done, you erase this part that is not shaded twice, this part. Okay? So only this part is shaded, then you draw again. Or you can identify the region earlier, only after that, after you found out the answer, then you shade that part, particular part only. So this is the part here. Only this part, huh? Second question here, B, for the inequality y is greater than or equal to negative x, y is less than 3, and y is greater than or equal to 0. So we look at the first one, y is equal to negative x over here. This is the graph. So if it is greater, we are going to shade the region above. Okay, I use green color now. Later on, I'm going to change it to different color so that you can see clearer. Okay, so this is y is greater than or equal to negative x. Now let's look at the second equation. So I'm going to use blue. So the second equation is y equal to 3 over here, but the inequality given is y is less than 3. So less than means we are going to shade the region below. Okay, this is the part here, region below. And then for the third one, so I changed the color again. Now I'm going to use purple. For y is greater than or equal to 0, this is line y, this is line x. So where is y equal to greater than or equal to 0? Y means it must be parallel to the x-axis, right? So this part here, I think I'm going to use a horizontal line. This is y is greater than or equal to 0 as long as it is on top of the x-axis. Okay, so now how are we going to identify where is the region that satisfies all the three linear inequalities? Can you see the region that is shaded 3 times? If you look at the region that is shaded twice like this, it is not the answer. You have to look at the region that is shaded by all the 3 colors, which is green, blue, and also purple. Can you identify it? Okay, I erase everything first. Huh? I erase all the ink. So it is actually, we see again, y is greater than negative x, so it is on top of this graph. And then y is less than 3 is down here. Y is greater than or equal to 0 is on top here. So can you identify the region already? The region is here. Okay, this is the region that satisfies all the 3 linear inequalities. We are going to learn on how to solve problem involving system of linear inequality in 2 variables. So you look at example 3. This one is from your textbook. State 3 linear inequality that define the shaded region in each of the following diagram. So here, for x is equal to 4. It is drawn with dotted line. Dotted lines means that the value is not included, right? So we only can use greater than or less than. But then the region is on the left. On the left means that it is less than. I use pointer so that you can see clearer here. So it is on the left means that we use less than. Therefore, the first inequality that we have is x is less than 4. Okay, For y equal to x plus 2, this is a line here. You can see the region is at the bottom, right? Meaning that it is also less than. And then the line here is a solid line. So it is less than or equal to. Therefore, for the inequality that is formed will be y is less than or equal to x plus 2. And then for the third inequality here, you can see the region is on top of the line. So it will be y is greater than or equal to negative 1 over 2x plus 2. Okay, now we look at the second diagram here. If you look at the second diagram, we also have three equations. So we look at the first one, y equal to 2x minus 4. This is the line. The region that is shaded is on top, right? So it will be represented using greater than or equal to because of solid line here. Therefore, the inequality formed up will be y is greater than or equal to 2x minus 4. And then for the second one here, this is the equation y equal to 0. You can see this is the line. The region it's shaded is below, therefore it will be represented using less than or equal to. Can you identify which one? Because this is a solid line, right? So we have to use less than or equal to. Y is less than or equal to 0. And then for the equation x is equal to 0, this is a line. And then the region is on the right, meaning that you have to use greater than or equal to. So x is greater than or equal to 0. Simple, right? Okay, now we look at example 4. Write 3 linear inequalities that satisfy the shaded region in each diagram below. So we have 1 equation, 2 equation, 3 equation to cover up this region. We look at the first one here. Because this one, it cuts on the y-axis, which means it is parallel to the x-axis, right? Therefore, the equation will be y is equal to 5. And then for the second line here, we have gradient. Can you see? So you need to find the gradient. Do you remember how to find the gradient? Gradient is the changes in the y-axis. So you can see this is 1, 2, 3, 4, 5. Or you can use 5 minus 0 and then divide by the difference of the x-axis. Also 5 minus this is 0. So 5 minus 5 divided by 5 minus 5 is 5 over 5. It is equal to 1. And then we need to find the c. Remember, the c is the y-intercept. The y-intercept for this line is 0. Therefore, the equation, it is just y is equal to the value of x over here. So y equal to x straight away. And then for the third one, this is the equation here. It cuts on the x-axis, right? Or it is parallel to the y-axis. Therefore, the equation is x equal to 0. Okay? X equal to 0. So, to write the 3 linear inequality, you just have to identify the shaded region. For y is equal to 5, this one here, it is at the bottom. Therefore, it's going to be represented using y is less than or equal to 5. I give you the answer here. Y is less than or equal to 5. And then for the second one, y equal to x. This is y equal to x. It is on top, right? So you are going to use greater than or equal to. So this is greater than or equal to. And for x equal to 0, this is a line. The region is on the right. Therefore, same thing, you are going to use greater than or equal to. Okay? Now we look at example 5 here. Madam Carol needs to select at most 20 pupils for a choir competition. The number of girls is at least twice the number of boys. Write 2 linear inequality other than x is greater than or equal to 0 and y is greater than or equal to 0, which represent the conditions of the selection of the competitors. Okay, here she needs to select at most 20 pupils, meaning that this is going to be represented using the sign of inequality, which is less than or equal to. Okay, this part here, at most, less than or equal to. So we are going to represent the number of girls here with the variable x, and then the number of boys with the variable y. Okay, they ask you to write 2 linear inequality, which represent the condition of the selection of the competitor. So first one is x plus y is less than or equal to 20. Okay, that's the first one. You make sure you have to make assumption, let x equal to number of girls and y equal to number of boys. So x plus y is less than or equal to 20. And then From the word here, the number, the second line, the number of girls is at least twice the number of boys. It means X. At least here means it must be greater than or equal to. So X is greater than or equal to. Twice means 2Y. Okay, so this is the answer. But we need to change this back. It becomes 2Y less than or equal to X so that you can draw on the graph later on. Okay. B, draw and shade the region that satisfy the above system of linear inequality. So for these two inequality, we need to draw the graph. Remember, if you want to draw the graph, you will need the table of value. So for the first one, I show you the table of value straight away. It's from your book actually. It's like this. When x is equal to 0, you just put any value. When x is equal to 0, y will be equal to 20, right? And then when x is equal to 20, y will be 0. Okay? For the second equation, 2y is less than or equal to x, so you find out 2y is equal to x over here. Just make assumption if x is equal to 0, then y is also equal to 0. If x is equal to 20, then y is equal to 10. I'm sure you know how to calculate this already, yeah? So you are going to draw a graph like this, whereby y-axis is representing the boys and then the x-axis is representing the girls. Okay, for the first equation here, x plus y equal to 20, when x is 0, y is 20, so it is this part here. And then when x 20, y 0, it is this part here. When you join up, you will get this line. So this is x plus y equal to 20. And then for 2y equal to x equal to 0, y equal to 0, so that's the origin. And then for x equal to 20, y equal to 10, this is 20, 10, so you will get this line for this one. Okay? Now, we are going to shade the region because x plus y is less than or equal to 20, so it is the region below. And then for 2y is less than or equal to x, also the region below, right? So the intersecting part is this region only for that two linear inequalities. Okay? Now, we look at C here. C. From the graph, determine the minimum and maximum number of girls when the number of boys is 5. They said from the graph. So you refer to the graph when the number of boys is 5. So from the graph, you go straight until it touches a line. The minimum number of girls is 10. And then the maximum number of girls is 15. Okay, that's how you get the answer of 10 girls and also 15 girls for the maximum. If you don't read from the graph, also you can get from the equation, right? If the number of boys is 5, you remember the inequality over here, the number of girls is twice the number of boys. So if the number of girls is twice the number of boys, it will be 2 times 5, which is equal to 10. And then for the maximum, you remember the first one here? The maximum, or at most, she only can choose 20 pupils. So if the boy is 5, then 20 minus 5 will be 15. Now we look at C. C2, C1 already done. Determine whether the conditions of the selection are adhered to if 8 boys wants to participate in the choir competition. Justify your answer. So 8 boys will be somewhere situated over here. Okay, do you think the condition is adhered to 8 boys? No, right? Because if 8 boys is not in the region. Okay, so no, because the value of y is equal to 8 is outside the shaded region. Okay, so that's all for today. If you like my video, do share it with your friend and give me a like. Thank you for staying with me, and I'll see you again in the next lesson.